Yes, that's what this little thing right here is. It's a microphone.
Can you see it?
Awesome.
No, we don't show up in the video. What you'll see on the video is what you see on the screen.
That's cool.
Weird.
This is your lesson 2-2 notes. This should go really quickly because this is the simplest of all type equations. And we'll just shorten up the title because all of this is about solving. But this is one-step equations. This is your heading. And if I feel like I'm having a problem getting you to take adequate notes, I'll start taking up notes and grade those every day as well. You should put everything that I put on the screen in your notebook. Okay? All right. The first term we need to talk about, well, actually, this is the only term for this lesson, but there is a word, or I guess I should say term, inverse operation, or operations. Does anybody already know what inverse operations are?
Doesn't that mean how like turning inside out?
Sorta, yeah.
Aren't they operations out in division?
That's true. Did you read that out of the book?
Mm-hmm.
You cheated. Inverse operations, and this is really what you need to know, undo each other. All right, what undoes adding something?
Subtraction.
Subtraction. What undoes division? Multiplication. And those are the big ones that we're going to work with today, those pairs. All right. So we have some properties to know, and these are properties of equality. And we're going to put this as a heading. In fact, I'm going to move to a bigger, I'm going to get all this on one screen, so I'm going to move to another blank screen, but don't skip space on your paper. And if you just write properties of equality one time, everything we write underneath this is one of the properties of equality, okay? So this is properties of equality. And there's not really a 1, 2, 3, 4, but what's the first thing you ever learned how to do with math? What was the first operation? Addition, right? So this is the addition property of equality. So we'll just write the word addition because we don't want to have to write property of equality 4 times, do we? Okay. I'm going to write this symbolically because you should know the words better. But I'd want you not looking at your book. For this, so try not to read this yourself because this is how you learn to read things in symbolic notation. And I see a couple of boys in particular who are staring at the page I just told you not to read. Okay? So, if x minus a equals b, then, and I will color code this for you, x minus a plus a equals.
You can't see that on the board.
Yeah.
Oh, the plus a doesn't show up good. It shows up really pretty on my screen. Let me fix that. Let me pick a better color. I know this will show up.
Yep.
Plus a, and then I'll come back to my yellow. All right, equals b plus a. All right. Well, if you look at the original equation, and this is how to read properties, and properties become really important because they will show up on the EOC. Okay. And part of the problem is the wrong set of lights is on. There we go. Is that better? You see the screen better? Okay. In the original equation, we had x minus a equals b. So what you want to do to see what the property is really talking about is compare the left side to the left side of this new equation. What did we change? Which I emphasized, and I emphasized it by writing it in white. I added a, yes? And what is the rule about equation solving? I can add a to one side as long as I
Add it to the other.
Perfect. Yes, ma'am. Oh, I didn't send him. Oh, I sent him because he didn't volunteer. He's a former student. Yeah, well, he just came wandering into the courtyard. Well, he insisted to me that he's actually from the, for the right reason, so I was about to let him go down this time.
Very cute.
Oh, well, I didn't say that class, but. All right, thank you. All right, bye. Joseph, great news. You're not going right now, but your elite pads are ready. So I'll let you go 5 minutes early to go get it. How about that? All right, so as we were saying, what we did to this was we took what was there and added a to it. And then what do we do to the other side? We did the same thing, right? So that's what the addition property of equality says. All right, well, let's take just a minute. We won't talk about this on every property. But what does it mean for two things to be equal?
They're the same.
They're alike. They're exactly the same, right? Like they are the exact same quantity, right? And when we're talking about math, right? Okay. So if this is equal, what would have happened if I had added a on one side but not the other? Would it still be equal? No. So if you get any little skips in the audio, that's what happened. All right. So now we're going to. I don't want to go in white. Let's go back to my yellow. Now we're going to go to, what was the second thing you learned? Subtraction. All right, now I want you to try to do this without looking at anything. All right, and you don't have to write it if you don't trust yourself. But if we start with if x plus a equals b, then tell me what the rest of this should say without looking at your book.
Then x plus a equals b minus a.
X plus a.
Minus a.
Okay, so now I got to switch colors if I'm going to stick to what we were doing. Minus a. Oh, wait, I'm sorry. Let me get my a on there. Apparently I didn't make the a. I thought I did. All right, x plus a. And then what?
Equals b
Minus a, right? Equals b. Minus a. So what does this say? What does the subtraction property of equality say?
It's pretty much the same thing. except you're doing
Exactly. It's pretty much the exact same thing. If I subtract one thing from one side of an equation, as long as I subtract that same thing from the other side, the equation's still true, right?
Yeah.
Okay? All right. And then I still wrote too big, so I'm going to need one more screen. But right underneath that, we're going to go to the next thing you learned. What was the next thing you learned how to do?
Multiplication.
Multiplication. Multiplication. So we're going to do the multiplication property of equality now. All right? And if I have x over a equals b, then we're gonna. What are we gonna need to do to get?
X over a times a.
That's right. We're gonna do x over a times a equals, and this takes me just a second to perfect. And so, if you had to say this in words, are we starting to see the pattern here?
It's the same thing.
It's the same thing. It's just a switch of the operation. So we got one more to write, and then we're going to kind of summarize. Yep, division. It's the only thing left, right? Division. And I used to not take the time to have students write these properties out, but the reality is that since you're going to be tested on it, I want you to have it in your notes, and at least we will have talked about it. So then if we have if ax equals b, then
ax over.
okay, well, I tell you what, let's do this. Let me undo that because I want to make that bar in white. So if I, and this one it's easier to show this way if I do it to both sides at once. Ax over b, I'm not over b. What do I need there?
Over
A equals b over a, right? So, and I want you to raise your hand for this one. Who wants to summarize, if you had to say in one sentence what all four of those properties tell us? David, I haven't heard from you today.
If you do something on one side, you must do it on the other.
Right. You can do, and there's an even more powerful way to say that, and this is what I will tell you over and over again. Somebody will say, is it okay if we multiply by a half? As long as you do what? To the other side the same, right? So you can do anything you want to one side of an equation as long as you do it to the other side. Okay? That's the moral of that story. Alright? So let's look at some really quick examples. Now, what we are going to get into today that we have not seen prior to 2-1, and we got kind of cut short on 2-1, but you should have seen some stuff in the homework about negative numbers. Is everybody good with those?
Yeah.
Any problems with any of that? Because nobody's asked a single question about the 2-1 homework, so I'm taking that as a good sign. So if you have any issues we need to talk about, you need to let me know. Alright, let's look at, we'll look at the guided practice at the bottom, page 85, and I'm going to jump to 3. I think y'all can handle it. Our first one, this is guided practice number 3, page 85, and you don't even need to open your book, it's not already open. Q minus 11, because I'll write it up here. Q minus 11 equals negative 5. Alright? What is the object of the game in solving an equation?
The opposite.
No. The object of the...
Find the variable.
One number on each side.
Yeah, get the same number.
Find the
Get rid of the,
variable.
Say that, David Tucker? Get the variable by itself. The object of the game is to isolate the variable. And y'all were kind of saying the same thing, right? Okay? But you want to isolate the variable. And in this case, our variable is Q, yes? Alright? So what do I need to do to isolate? Well, what is keeping Q from being by itself here? Minus 11. Now this is a very important thing for you to make clear now. Well, it's really simple. When you're trying to isolate a variable, you have to get rid of whatever's getting in its way. And when I say getting in its way, keeping it from being alone on that side of the equation. Does that make sense? Okay. So what do I need to do? I need the inverse operation.
11 plus negative.
So we're going to add 11, and this is how I want it shown, underneath it. And then I want you to put a bar. Okay? Because now we're going to add like terms, right? Well, there's nothing to add to the Q, so I keep it. What happens when I add plus 11 to minus 11? They cancel each other out. We have 0, so that leaves us Q on the left equals
0.
16.
16.
Ooh, okay. All right, look at it this way. Look at it this way. Let's say you owe me $5. What does that relate to in this equation? Negative 5. Let's say you owe me $5. And then while you're at lunch today, somebody paid you back $11 that they owed you.
So you
Right? So you walk in the room, you're like, Miss Twitty, great news, I can pay you back the $5 I owe you. So you pay me the $5. Do you have money left?
Yep.
How do you know you have money left?
Because you got more than you had to give
Because
me.
you got more than you owed me, right? So that's how you decide it. Because remember, what's the rule when the signs are different? Subtract. So I would do 11 minus 5, right? 11 minus 5. Yes?
Yes.
And then how do I decide the sign?
The bigger number.
That's right. You take it off the bigger one. So our 11 was bigger, so it's positive. So our answer should be positive because we subtracted. The other way we can do it, because thank goodness we have some calculators at our disposal, you can type that exactly like you see it. So what you would type in your calculator to check your answer is negative 5 plus 11 to make sure that you actually get 6. Yes?
Is it like a rule that you have like if you have a smaller number with the bigger number, it's negative, and if you have a bigger number,
No.
if they match, positive don't match negative?
That's all.
Or is that wrong?
Let's talk more as we go. Okay? I hope you had some practice with that in 2-1, did you not? Oh, well, they didn't give me a good... I'm going to back up and do one with you just because they didn't give me one like that. You got a question, David?
Yes. Does the number being bigger, what if negative 5 was negative 12? Would negative 12 be the bigger number? Or
Right, yes. When we say the number, we mean ignoring the sign.
Okay.
And another way to say that, which would be more explicitly accurate, is to say which one is farther away from 0.
Okay.
Right? Because negative 5 would be 5 steps to the left, and positive 11 would be 11 steps to the right, so the 11 would be further away. So that's a cleaner, if the bigger messes with you. And believe it or not, that's a question we have all the way through calculus. Because I'll be talking about bigger numbers, and they're like, wait a minute, do you mean bigger negative? You know, so, yeah, that's a good question. Well, maybe you can talk the rest of us through it. What do we need to do here?
First you need the subtract something and the plus something.
That is correct.
And do it to the same two.
That's exactly right.
Break down the y
Yes.
to the equal sign, and then that would be 3
Why is that 3?
because the bigger number is 10.
That's right. The bigger number is positive, and I'm taking away the smaller number, which means I'm still going to have money left. So it's like if I got $10 in my pocket, and you're gonna buy something for $7, you got 3 left, right? If you think of it as money, somehow that makes everything easier. Not really sure why sometimes, yes.
So the bigger number, you always have to look at the bigger number to determine what your answer is going to be.
The sign of your answer. The sign of your answer. And you have to be careful about saying always the bigger number, because if they're the same sign, you add and keep the sign, right? Because like if you owe me $5 and then you borrow $5 more, what do you owe me? 10. So then now you have negative $10 because you owe. You see what I'm saying? So you have to. That's why I said let's talk more about that as we go. All right, good discussion. Let's jump to 6. Since I think we need more practice with negatives than we do anything, so that's why I'm kind of jumping around trying to find some with negatives in it. Negative 65 equals negative 5y. All right, what do I have to get rid of, Zachary? Nope. How do I know, Madison? No, go ahead and tell me. What do I need to get rid of?
Get rid of the negative 5.
Why do I need to get rid of negative 5? Because that's what's in the way of y being by itself, right? Okay, what's it doing to it? What's the inverse operation, Austin? Yeah, I was talking to Austin. He didn't even hear me call his name. And he's still laughing. I was talking about Austin. Yeah, so Austin didn't even hear his question. That's what happens when you think you're smarter than me. All right? So what is the inverse operation of multiplication? Anybody? Division. So we're going to divide both sides by the same number with the same sign. Okay? And then on the right, what's going to be left?
Y.
Just the y, which is what we want. Which means we know that we're about to get our answer. What happens when you divide a negative by a negative?
It's
It becomes positive. And here's where you can use Twitty's quick division. If I'm working without a calculator, how many times does 5 go into 6?
13. I mean, 5 6.
1. And then if I put the 1 in front of the 5, 5 goes into 15. 3 times 13.
I use it as a clock. Like 65, that's just after 26.
I'm like, what the fuck?
Yes, ma'am.
I didn't get why you did division.
Because what is the negative 5 doing to the y?
It's blocking it.
No, don't block. Blocking is not a math word.
Well,
You have four choices. It's either adding, subtracting, multiplying, or dividing. No, it's not. What is it? There's no symbol between the 5 and the y, right?
The negative 5 is multiplying. by
Yes,
5.
the negative 5 is multiplying y, so I divide to get rid of it. Yes? Okay. All right, one more of those. Well, they didn't give you a division one. Never mind. We'll just move on. Oh, here come the division ones. Turn the page. All right. Let's look at number 9. Because we've done all the properties we need for this one. T over negative 3 equals 9. Turn the page. Turn the page. Right there. Guided practice, number 9. T over negative 3 equals 9. That's the equation, right? Okay, what question should we start ourselves with?
What's blocking the
What? Don't say blocking. Blocking is not a math word. That is a football word. That is a volleyball
Just
word.
keeping the variable by itself.
It is what is in the way of the variable being by itself, right? So basically, the first thing you got to do is find out where your variable is, don't you? Because on some of them it's been on the left and some it's been on the right. I need to get it by itself, and to figure out how to do that, I have to figure out what the number that's there is doing to the variable, right? And what does this mean? It's division, right? So this is t divided by negative 3 equals 9. So what do I need to get rid of? I need to get rid of the division. And this is how I want you to show me that. And if you show it any other way, you won't get full credit. And that may not seem fair, but this is Twitty world, so Twitty makes the rules. Deal with it. All right? So what I want you to do, I want you to put parentheses here, and I want you to put negative 3 in parentheses there, because what do parentheses mean when there's nothing in between them? Multiplication. Put parentheses around the 9, and parentheses negative 3. Is there a problem? All right? It's not weird. It's algebra. Okay? It will be done my way, or it will not receive full credit. You don't have to like it. You just have to do it. Okay? If you want the grade you ought to have. And if you have a problem with it, we can have a one-on-one conversation about it, but I don't want to be interrupted over it. All right? So what happens when I do an inverse operation? it makes it go away, right? So on the left, I'm left with t,
Negative.
and then I have a positive times a negative. When the signs are different, it's negative. When it's a product,
Negative 27.
27. And that's why you don't need to work ahead of me, even by example or on homework or anything. You should not be working ahead of me, because you don't know how I want you to do it till you see my examples. And your work should look like my examples. And they are my examples for a reason, because I know what you need, because I teach a college level class here at Camden High School. Okay, so I know where you're going to end up. All right, let's do one more of those. Let's do number 12. We have a over 5 equals negative 11. What is the first question I should ask myself?
What's
Okay,
causing
what
the
is being
variable
the way
the
What do I
integer.
need? And here's the safe way to say it. What do I need to get rid of?
the negative, I mean the 5.
The 5. Why?
Because it's in the way.
Because it's attached to the variable, right? Okay. Attached is a safe word. All right. What operation is that?
That's division.
And what is the inverse operation?
Multiplication.
So we're going to multiply both sides by,
5.
and we're going to show it with parentheses. So we put a 5 in parentheses out front. And what's going to happen on the left? Fives go away. I'm left with a. What is negative times positive?
Negative
11 times 5?
Negative
55. Get the idea?
Yes.
Okay. Let me ask y'all a question before we cover one last thing for this lesson. Dividing by a number is the same thing as multiplying by
Negative?
the reciprocal. Have y'all heard that before?
Yeah.
Okay. All right, let me show you how this works. Now, I'm going to do this one a messy way, and I'm going to show you this by example rather than giving you a rule. Jericho, you need to uncross your arms and sit up straight. Slide your fanny back in your chair. There you go. All right. We're going to jump on down to number 13 as our example. All right. And we have 5 over 6w equals 10. Okay. Now, first of all, why does this one look different from what we
Because
just
it's a
did?
fraction.
Because there's a fraction there, right? And it's not a division problem, which was the last one we did, right? Those last couple were, we have a multiplier. So how do you get rid of a multiplier?
Divide.
You divide, okay? So like I said, we're going to do this in a long and messy way, and then I'm going to show you the short way,
So
okay? So we're going to divide by 5 6. Right? I mean, technically, is that not what we did on the others? So I know that doing that will get me W, all right? But that's kind of tricky, so I want to rewrite my division problem as a multiplication problem. So I put 10 over 1, and you should always write it that way just to emphasize what's about to happen. Dividing by 5 6 is the same thing as multiplying by 6/5.
So can we cross multiply? I mean, cancel 5 and 10?
Yes, but I want to make sure everybody's with me. I saw a couple of faces.
How'd you get 10 over 6?
Okay, grab your calculators. Grab your calculators. And I want you to type exactly what I tell you to type. 10 divided by, and then put a left parenthesis. Your calculator should be on your desk ready to go. 10 divided by, and then in that parenthesis, I want you to put 5 divided 6, close parentheses, math, enter, enter. 10 divided by, left parenthesis, 5 divided by 6, close parentheses, and you get 12. Okay, so that's going to be our answer. Let's just go ahead and write that down. All right, now I want you on the next line to type 10 times 6 divided by 5.
Math and under. Did you also do math and under?
Just do it. Just hit enter. It'll come out. Or if you did math. All right. So what did you just notice?
It's the same thing.
It's the same thing. Okay. If I said, okay, here I only have 1 cookie and 2 of you want it. So, and I say, okay, well, did each of you take half? What does that mean you're going to do? How are you going to divide the cookie? You're going to divide it into how many pieces? 2. So dividing by 2 is the same thing as multiplying by a half. if I say half of 4, it's really divide 4 by 2, right? You see what I'm saying? So we're going to harness that rule. And the shortcut to doing this problem, instead of having to write all that out, because this bit right here gets really clunky, doesn't it? That's a lot to have to write out. This is sort of like the theory behind the shortcut we're about to do. So the shortcut you want to learn in this lesson, if you didn't already know it, and I know some of you have sat through this class before, so you think you're already experts, but if you were experts, you would have aced the class and wouldn't be back. And I'm not saying you made bad grades, but the fact that you're taking it over is not a reason you should argue with me about everything I do. It doesn't help any of us. All right, so we're going to redo number 13. And at some point, we'll involve some parents in these conversations. So if we have 5, 6W equals 10, the shortcut to accomplishing exactly what we just accomplished is that we are going to multiply both sides by the reciprocal of whatever's in front of x, or w in this case. So then that cancels the 6's, that cancels the 5's, and leaves me w. And then, as Armani was pointing out a while ago, I could cancel this down to a 2 to get the 5 out of the bottom, so 2 times 6 is 12, and I get my answer. Now, I am going to emphasize for this class the use of that calculator, because that's what's really going to help you make good grades on your EOC, okay? But at the same time, those calculators don't follow you to your next class. If you don't own your own calculator, or you're doing something that the teacher won't let you use a calculator, you want to be able to do what I just showed you. So that's why I'm always going to keep showing you the ways to do it without a calculator. Yes?
I'm still confused on why you switch 6 and put 6 over 5.
Because dividing by a fraction is the same thing as multiplying by a reciprocal.
And multiplying is easier.
That's what we just did on the calculator. That was the whole point of 10 divided by 5, 6, and you got 12. 10 times 6 fifths is equal to 12. Okay? So what we just did is how we're going to do it. So let's do a couple more using that shortcut. Any other questions? All right. Let's look at number 14. Now, when you write down a problem like this, let me show you something you should pay attention to. Okay? You should leave a little bit of space and then write the problem over here, because when you look at that problem, what are you already thinking we're going to have to do?
Multiply by the reciprocal.
Multiply by the reciprocal. I want to leave myself room to show that work. And I've been kind of writing it on top of the number, but that can get really messy. Okay? So that's your way of not making it messy. Let's pick this number. No, that's too close to the same. All right, so I'm going to multiply 2/3 by what, Austin?
All by 3 over 2.
By 3 over 2. And if I multiply that side by 3 over 2, what else do I have to do, guys?
Multiply the other side.
Multiply the other side by 3 over 2. Stick a 1 under the 14. And now the 2/3 cancels the 3/2, and I'm left with p. And what happens with the 14 and 2?
7.
It's 7, right? So that cancels the 2 off the bottom. This becomes a 7. I have 7 times 3, which is 21. Awesome. Y'all get the idea? We need one more. Let's do one with a negative. In fact, we'll do it on that same screen. We got plenty of room. All right, let's do number 16. And we have -8. Again, whichever side you write first, you want to leave a space, because we know, what are we going to have to do to solve this one? I'm going to have to multiply by a negative
1/8.
504.
Negative 5 over 4?
-4?
No.
No, you're right. -5 over 4.
Okay.
Okay, how do I know? Where do I start? What do I have to orient myself with? The variable, right? And the variable's on the right, so what do I have to get rid of? Negative 4 fifths, right? So that's what tells you what to multiply by. All right? So make sure you're really thinking before you start writing each time. All right, so I'm going to multiply by -5 over 4. Somebody wasn't listening. Why are we multiplying by? If you just said 8, I want you to tell me why we are multiplying. Do y'all know what the number sitting in front of a variable is, like these problems? What is the name for it? Starts with a C. It's cosine. Coefficient, yeah. Because your coefficient's a fraction, this is your strategy, okay? All right, and so on the right, the 5's cancel, the 4's cancel, the negatives cancel, and leave me V. Yes? And on the left, I stick a 1 under the 8, and what's gonna happen?
You're gonna have to
What's a negative times a negative?
Positive.
Positive. And remember, anytime there's an even number of negatives, they cancel. All right? 2 is even, right? And the 8 and the 4
Cancel.
leave me 2. So I have 5 times 2, which is
10.
10. And our work here is done.
I forgot that we have to do the cross.
Well, either that or use your calculator.
What did you do when you got the canceled? Oh, never mind.
You good? You sure? Anybody else with questions? Because I think that wraps us up for 2-2.
Yes.
You ready to jump to 2-3? All right. And you can do it on the same page. Just draw a big line and write, or you can start on a new sheet or the back or something. Lesson 2-3. What comes after 1? 2-step. So we're doing 2-step equations also today. Two-step equations. Now I'm going to teach you a strategy different from anything you've ever seen before. Shocking. And you won't find this in your book. So wherever your head's been for the last few minutes, it better find its way into this room. Okay? Here's your strategy. That's it.
Sad
SADMEP. Recognize those letters?
Isn't it PEMDAS backwards?
It's PEMDAS backwards. Okay, remember when we wrote PEMDAS in our notes? And y'all have done, honestly, I think y'all as a class, I would say, if Mr. Matthews asks me when I have my meeting with him tomorrow, which was going to be yesterday but got delayed because it took us a while to get that screener test out of the way. But if he asked me tomorrow, I would say I'm pretty confident that, give or take 1 or 2 people, this class 100% understands PEMDAS. And that's a very important thing. I've had lots of algebra classes, I wouldn't have been able to say that. It was an ongoing struggle. I think y'all are good with that, okay? Remember when I wrote PEMDAS on the board and I put the parentheses? Why did we put, and your paragraphs kind of told me you didn't really understand this, by the way. Why did we put the parentheses?
Because,
On PEMDAS. So, like, why are the M and the D in parentheses together?
oh, because, they're, you gonna hurt her. What come out right?
Help her out, hubby.
There are groups.
What do you mean they're a group?
Like multiplication and division go together.
What do you mean go together? There's a specific thing. How do I do them?
From left to right.
From left to right, okay? When I do the multiplication division step, I do the multiplication and division as I get to it working from left to right, yes?
Yes.
We know you're not married. It's just a little joke. Everybody's all blushing like they're married.
Can't take the seat.
Okay, so we're going to use the same idea here, but the good news is here you won't be adding and subtracting. You'll either be adding or subtracting. That's kind of the way it's going to work, all right? But we also I wrote the PEMD, I wrote PEMDAS on the board, put parentheses up there. And then what did I write underneath it? No, I don't mean like an explanation of the words. There was a phrase I told you. Because what does the P stand for? Parentheses. And what does it mean? You really start, if you're doing PEMDAS, you really start where? Inside the parentheses, right? Inside. Because remember I told you to write inside out? Especially with the hubby and everything. Hubby wasn't acting like I'm a lunatic up here for a minute. All right. SADMEP, outside in. Don't say it, Zachary. It was a joke. You can laugh. I'm not picking on you. Just trying to get you to be involved here. I want my capable people participating. All right. So basically, that's your strategy. And we need a strategy because of the fact, and we're just going to jump right into the examples because learning to solve equations is doing them over and over and over again with a good guide, and I am your good guide. Okay. So here we go. We're now at the bottom of page 91. If you care to join me.
No, I think that's.
And we are at 5x plus 9 equals 24. All right, now don't do anything until you watch me do this. And I'm not going to make you do this, but let me rephrase that. I'm not going to make you do it initially, I'm going to let you try it without it. Now, if you want to use it anyway, you can, and I will never mark off for you doing this. But if you are getting the wrong answer over and over and over again, I'm going to insist that you do what I'm about to show you, all right, to relate this back to the SADMEP we just did. All right, first of all, I need to why am I going to focus in this equation on the left side? What brings my attention to the left side?
variable.
The variable. I find the variable, and that's where I got to do my work, right? So what do I know I have to get rid of? And what's the 5 doing to the x?
Multiply.
So we're going to put a little m above it. What is the 9 doing to the x? Adding. So by SADMEP, which one of those comes first? Whoop! SADMEP. Adding comes first, right? So we're going to get rid of the adder. How do we get rid of an adder? And I don't mean a snake. We subtract 9 from both sides, draw a line. When I take 9 away from the left, what is left? 5x. And what's left on the right? 15. Yes, because if I got $24 and I spend 9, I got 15. And now what do I have to do? Divide by 5. Because once I get that first step done, do you notice that the last step is the same thing we're doing in the 2-2? So we have x equals 3. Pretty simple?
Wait, so,
Yeah.
so basically you just switched around.
Yes, we're doing PEMDAS backwards. Because you use PEMDAS for expressions and come back over here and or write this out beside this somewhere or something. Write for solving equations. SADMEP is for solving. PEMDAS is for expressions. Yes?
And for adding, subtracting, and multiplication and division, for this, would they also be going from left to right or right
Well,
to left?
for the ones for two-step problems, it's going to be typically it's going to be a number times x plus a number, or it's going to be a number times x minus a number. So you're either going to be getting rid of an addition or a subtraction, and then you're either going to be getting rid of a multiplication or a division. Okay. Now we'll come back to that question in more detail on tomorrow's lesson. Yes.
So every time you do an equation, you always do it this way? So
Yes. It always works. Okay. I love the participation today. I can't wait to brag to a couple of my friends that old Tuck came through for me today. Good old Tuck. All right. Let's do number 2. 4y minus 4 equals 16. Now let me tell you something that will speed your understanding and limit the amount of time you have to spend on homework. When you write a problem down on your paper, while you're writing the problem down on the paper, you should be thinking, okay, this is a whatever problem. This is a 2-step problem. Where is the variable? On the left. So as you're writing it, what do you already know we have to get rid of?
The four.
Both of the 4s, right? What is the first 4 doing to the y? Multiplying, so we're going to put a little m there for multiply.
Subtract.
And the other one is subtracting.
Do subtraction first.
SADMEP, S comes first. We're getting rid of that first. The subtracting 4,
So we add 4.
add 4. I love you guys. And we get what's left on the left?
4y equals 12.
That would be the whole thing. We'll take it. 4y equals what? 20.
25.
What's 16 plus 4?
16 plus 4 is
Oh,
20.
add 4.
Slow down, David. Slow down. Focus. Campbell, wake up, buddy. Give yourself one of these.
I was just trying to stretch my neck.
No, well, why do your eyes do this when you stretch? Yeah, when I stretch my neck, watch, my eyes don't change. Stretch my neck, my eyes are open. I look at you and you're like he's having some sort of little seizure back there with nobody looking. And what does that give us? Awesome.
Wait, Miss Twitty.
Yes.
So when every time we begin a problem like 4y minus 4 equals 16, we always have to do multiplication and subtraction, like
Label them.
determine which one we do first.
That would be a good strategy, especially, and there might be some of you that you like that because it kind of keeps your thinking cleaner. Do it on the first few, but by the time you do the 4th or 5th problem, you might realize you don't need it anymore.
Like
When you can get the right answer without using those labels, then do it. But I would suggest using them. I'm not going to take off if you don't use the labels. I just want the steps shown the way I'm showing you. Fair enough? Undo that. Okay. Let's do number 3. Why do you think I want to do this one? Actually, a couple of reasons.
Because it has
On the
different.
right side.
It's on the right side.
That's right. The variable is not on the left side, and
The variable's in a fraction.
yeah, the variable looks like a fraction term, so we're gonna have a slightly different thing going on here. Okay. All right. So where do we put our focus to start solving this
The
one?
variable.
The variable, which is on the
Right.
right side. Okay. So we have how many things to get rid of? Two, and it should be on the whole assignment today. The correct answer to that for 2-3 should be that I have 2 things to get rid of. Which one do I get rid of first and why? Okay, so I have to decide what they're doing to decide which one to get rid of first, right? What is the 7 doing to it?
Subtract.
So we'll put a little S above it. How about the 3?
Dividing.
So we're gonna
we
put a
do
little D up
subtraction
there,
first.
right? So we get rid of the subtractor by adding. Perfect. And if you owe me $1 and you walk in the door with 7, how much you gonna leave? You're gonna have 6 left. And then that's gonna leave you Z over 3. And notice when I write the second step, I don't need the label anymore because there's only one thing left to get rid of. How do I get rid of the dividing 3, Jericho? The question was, first of all, the statement is, quit propping. And the question was, how do I get rid of this 3? Multiply. Why am I multiplying? Because it's the inverse of anyone? Division. So if I multiply that side by 3, I have to multiply this side by 3, and I get 18 equals Z. And I do the European Z so you don't think it's 2.
It looks like
Yes.
an E. Just
I'm
weird.
confused why you,
Looks like
I wanted, you know how negative 1 is there? Why didn't you label negative 1? Because I.
Okay, because what are we labeling? Look at all the examples we've done with our labels. Did we label the number on the other side? No. Why are we labeling? To figure out which one to get rid of first, right?
So you always.
And I only get rid of what's with the variable. The negative 1, why, and this is a very important question, why is negative 1 not with the variable? Because it's on the other side, right? Does that make sense?
So you number all the ones that's on the side.
Yeah, you label whatever's with the variable, because that's what you've got to figure out how to get rid of.
And why
Which
did
is,
you do times 3?
okay? Well, first of all, what was left? In fact, let me undo, and I can undo this and show you. So, all right. In fact, I'll keep going. All right, that's where we were, right? Okay. I want the Z by itself. What's in the way?
The divided by 3.
The divided by 3. What's the inverse of dividing?
Times 3.
Multiplying. So watch. What did we do? We times 3. And if we do it there, what else do we have to do? The other side, right? And then when we multiply 3 by 6, we get 18. That's our answer. Good job? Everybody good? That is not our bell? We're actually in pretty good shape on time to cover 2 lessons. All right, but we have to cover 2 lessons to get where we need to go.
So now we're gonna start homework.
We're not done yet. We still have notes to take. If you absolutely positively can't wait, but you're going to miss some lesson. All right, the only other thing they're going to throw at you is problems like the guided practice at the bottom of page 92. Turn the page and look with me.
That's that variable in there twice.
What's different about these equations?
Has 2 variables.
2 variables. Okay, now for those of you, and I don't think I told y'all this yesterday, but your test corrections, as I promised, for what was worthy of credit, you got half credit back on your test. Okay? Now, if you look in Power School, if your parents look in Power School, your test grade's going to look like it's the same, but I did the corrections as a separate grade, so I'll have a record of what part of it was corrections. You with me? But it adds in the same. All right? On the assignment that I made after the test Friday, that a good number of you showed up without yesterday, or showed up with not done sufficiently for credit, I decided that since it was a weekend assignment and it was kind of an extra thing thrown in, that I would count it as a bonus grade. So I gave you bonus points if you did it. Okay? So if you wonder about why your grade came up like it did, because some of you came up 2 or 3 points over it. I wanted you to understand. Now, but the reason I brought that up is that there were some kind of warm-up problems for the chapter related to this idea. How would we classify 4W and 2W? There's a term for that. What kind of terms are they? They're like terms, aren't they? Do y'all know what like terms are?
Yes.
Yeah.
Have the same variable.
Same variable
Different
and the same exponent, right? So if it was like a power, so W squared and W squared would be like terms. We're not there yet, but we might see those. So like terms means they have the same variable to the same power. Well, these are both W, right, with no exponent showing, so that's to the same power, right? Okay? So that means we can add them together. That's like $4 plus $2. So this is 6W.
So just turn to like.
Okay, so now it's just a little one-step equation. What are we going to do? Divide by 6. The 6's cancel. We get W equals 4. Simple enough?
Yes.
That's really all that is. All right? All right? 2 more examples we're going to do together, and then I'm going to give y'all, you're going to have about 30 minutes to start your assignment. So you'll probably get all of your 2-2 assignment done, and then maybe even get to some of your 2-3 if you work diligently at it. But don't start it now, because you need to go over these with me. Number 7. I'm going to read this, and I'm going to pause because you need to tell me what that tells me, okay? Number 7 says the output of a function is, pause. What is the output? What is the output?
X, the X.
Why?
Y.
Okay.
Well, I know why.
Okay, how do we decide whether it's X or Y? Do you remember what the other word was? Output and input. And output and input go with domain and range how?
Wait.
Range
Is
is
the output? What's the
I'm
output?
listen. Let me guide the conversation, Emma. Listen to what I said. Output, right? We're trying to figure out what it is. We know it relates to input, yes? And remember I said, and if you go back and look at your notes, you don't have to do it right now, but see if you can remember. I said, remember these words connected? Okay. Input is which one?
Domain.
Okay, it is domain. And if the input is X, what's the output? Okay. Let's try that again. Yeah. Output, input, and y'all said that was X. Or no, you didn't say it was X. What did you say? Domain. And so what's the output? Range. Okay, now let's put the letters with them. X goes with domain input X. Range output Y. Okay, so when I see the word output, I should write on my paper Y, and then listen to what there's another key word in what I read. The output of a function is.
Multiplication.
What is? Equals. Isn't that the math word for is? Equals, okay? Is what? 5 more than, okay? Well, if I have $10 and you have 5 more,
Plus 5.
we're going to have, that's right, leave a space and put plus 5. So far, so good?
Yeah.
Okay? 5 more, and then what comes after the then tells me what to put in the space, right? -2 times the input. So what goes here?
-2.
Times
Negative 2x. -2 times the input would be -2 times x, wouldn't it? All right? Find the input when the output is 11. That's right. So now on the next line, I'm going to put, in place of y, I'm going to write 11, and then I'm going to write everything else the same. So what does this look like? Those equations we were solving a minute ago.
Yeah.
Where do we start?
The variable.
Yeah.
Find the variable. So we're going to work on the right, and that tells us we got to get rid of what? 5 and -2. In what order? Why the 5 first?
Because it's backwards.
That's right, because A before M in SADMEP, right? So we're going to do what to get rid of the adding 5?
Subtract 5.
Subtract 5. And I just subtracted 6, and I don't quite know why. Sorry. Just seeing if you're paying attention. All right. I guess I was getting ahead of myself, because what is 11 minus 5? 6. And then that gives us -2x left on the right. By?
Divide by 2.
By what?
-2.
-2. And we get -3 equals what, Santiago? Equals x.
X, because y will equal 11 and x
And just for fun, let's just show off a little bit. If I were going to take that information and put it in a coordinate point form, what would go where?
-3 will go.
Negative 3 will go first.
Negative 3 will go first.
And y will be 11. We learned it last year.
My heart just grew a size. That's awesome.
Can you hurt us?
It's so nice to teach freshmen who actually learn things at the middle school.
Of knowledge. Ooh. Was that directed to?
Why'd you put 11? Because 11.
Because that was the output. What did we say? Output range, right? Domain rangey? Remember that little attachment?
I remember that.
Okay. All right, one more. I'm going to read it. You tell me what to write. I'm going to pause. The output of a function is, what do I write? Y equals,
Space.
David's getting his loud voice out, his stage voice. The output of a function is 4 less than,
You don't put that.
Space -4.
that's right, space, take away 4. Because if I have $10 and you have 4 less, how much do you have? 6, right? Okay, less than what? 4 times the input. So what do I put in the space?
4x.
Gosh, y'all are just, oh, you just don't know. Now if I could get everybody on board, I might cry. Y'all will know you've won me over for good when I cry because you're so good. All right. Find the input when the output is 3. Where do I go from here?
So you put the
3
3
equals 4x minus 4.
Listen to this. Y'all are so freaking smart. All right, now what?
We go see what the variables beside.
That's right. So what do we have to?
I mean, subtraction come before.
We got a multiplying 4 and a subtracting 4, and we get rid of the subtractor by add 4 to both sides.
7 equals 4x.
7 equals 4x.
Divide by 4.
And then divide by 4. So x equals 7/4. When it won't go, you leave it. Okay? So for the grand finale, what's that point?
That is 7
7/4
fourths.
and 3.
Perfect. They're awesome.
Yeah.
Did you say, yeah, we're awesome? That's what it sounded like, didn't it? I said, y'all are awesome. Yeah. Well done, guys.